We're covering the makeup of bone. How do we actually create a bone? Later we'll talk about growth and development, but we start out with what are the actual cells that give me the tissue that we see. Remember, there's 4 types of tissue. And when we look at connective tissue, we said it's specialized cells that make a matrix. When we learned epithelial tissue, we described one of their characteristics as cellularity with tightly bunched cells, not much material in between, relative to the other tissues. When we cover connective tissue and look at bones, now we have cells that become specialized because they're making a matrix. Remember, a matrix includes 2 things, protein fibers and ground substance. So we're describing this. When we look at the cells of bone, it only accounts sometimes up to 2 to 3% of all of the tissue. The rest is what it makes, which is the matrix. And then we have a balance of some cells that help to create a homeostatic balance during repair and building the bone as we grow up to 25 years old. So let's cover these cells, starting with mesenchyme or mesenchymal tissue. Mesenchymal cells are the basic embryonic stem cells for which all connective tissue will arise. So anything from our dense, regular connective tissue to our cartilage, we start out with mesenchymal tissue. We have a basic starting point. So these are the embryonic stem cells. Once we learn that we're turning into bone, meaning there's markers in the DNA that will be activated to say we're going to be at this place, we're creating bone, mesenchymal tissues will then turn into the specialized cells that make bone. So we start with the stem cells called osteoprogenitor cells. So mesenchymal cells turn into osteoprogenitor cells. Remember the key term of differentiation, that cells change over time. No different than you change over time. You go from a baby to a child to a teenager to an adult, and you change as you get older, but it's still you. So mesenchymal will change into osteoprogenitor cells. These are now the stem cells of bone. So we now mature to where we get to the point where we're going to start going through mitosis. Osteoprogenitor cells keep dividing, and eventually will then turn into the cells that actually do the work. So osteoprogenitor cells are still stem cells, but they're specific to bone. They will turn into osteoblasts. Osteoblasts are the young cells, the baby cells for B in blast, B for baby. Osteoblasts are the ones that are going to secrete the matrix. So they're actively doing something and creating the foundation. To me, it's like creating the house. It's the people that live in the house that are building it. There's only a couple of people live in the big house that they're building. Remember, we said bone cells account for only sometimes 2 to 3% of all the bone, depending on the bone. Osteoblasts get older and become osteocytes, and they help maintain the matrix. Remember, osteoblasts, as they get older and they become cytes, they now form that bubble around it called a lacunae. So osteocytes and lacunae. So now you have 2 cells. The younger cells secrete the matrix. Osteocytes are the ones that help maintain it. Now we finally get to the point to where all that differentiation occurred and you have actual bone material. Now I put this in red for osteoclasts. Osteoclasts come from what we call macrophages. Remember, leukocytes are white blood cells. These are macrophages. Macrophages engulf and eat things. And so osteoclasts with the C, what they do is they break down bone, which is helpful when I break a bone and help to repair and remodel it. So in theory, it goes back to the same shape. Remember in a previous video, we talked about long, short, irregular, flat, the types of bone. So based on the DNA, it knows how to regrow it to the same shape. And when we look at osteoclasts, they help for, as the bone develops over time, when my bone grows, it's getting bigger and bigger. So if I think about my femur, the biggest bone in the body, when I go from 10 years old to 20 years old, it's increasing dramatically in size. To help support the bone, I got to make sure there's enough inside material to make it function. So the diameter will increase, but then I have to allow room for it to develop. So osteoclasts will help create that room, and specifically they're breaking down the inside to allow more structural support. So intuitively that seems off, but if I'm going to build the house and I keep adding the walls to it, I'm going to need to do more inside the house and specifically give me more room for it to function. If the body needs calcium, Osteoclasts will break down some of the bone to demineralize it and take some of that calcium and put it in the bloodstream. So osteoclast is a homeostatic balance, and it helps us to create the bones, remodel it, provide that calcium in the body when needed. And so we're finally at that point where we create that balance, and let's get into the matrix. So the matrix, remember, is made by osteoblasts. So osteoblasts secrete the matrix. Our matrix includes two things: protein fibers and ground substance. Protein fibers, 3 types: collagen, elastic, and reticular. Up to a third of all of the matrix is including are collagen fibers. Remember, collagen fibers are the most abundant and they're the strongest to give us tensile strength. So these protein fibers help with that supportive flexibility. And then the ground substance is the material. Remember, it could be a fluid, it could be gelatinous, it can be hard. In this case, it's hard like bone. Calcium is our primary mineral that we use. Calcium phosphate and calcium carbonate are the primary compounds that we see in bone. Phosphate is a strong material that helps with compression. We see phosphate in the enamel of our teeth. Calcium phosphate is one of the hardest materials in our body because it's got to support that compression. You think about my teeth. As I'm constantly chewing, it supports that compression as I squeeze onto my carrot that I'm eating. Calcium carbonate is similar to what's in an egg. So when you think about an egg, it's got a lot of calcium carbonate to it. So we see other species were similar in structure and function in how we do things. So I have the fibers that provide that flexibility, ground substance to help support that compression. So all of this contains majority of what you see in bone. And the body can keep rebuilding it. Remember, we said that in epithelial tissue, we said it does the most regeneration, that I keep rebuilding this over and over again. All of my epidermis can regrow in a month. Bones still grow and repair itself, and we know that when we break our bone. But a lot of our skeleton is completely remodeled and replaced every 7 to 10 years, depending on your health status, genetics. But as I get older, that'll slow down. But we keep rebuilding it to create that strength because it's the structural support of our body. This is the makeup of bone.